Cleansing agents. In this section, we will be studying about detergents. Detergents or cleaning agents, that's most important to note, are basically of two types. They are either soaps or are detergents. Now let us first talk about soaps. Soaps actually are sodium salts of long chain fatty acids. They are prepared by a process or the reaction called saponification, in which the oils of fat, this is oil of fat, like this is triester of glycerol and long chain fatty acid, which is the stearic acid. So this oil of fat, whatever it is, which is taken, like this one is basically is a fat, the stearic acid, C17H30 finds a triester with glycerol. This on hydrolysis with NaOH gives glycerol and the sodium stearate, which is here is soap. Now soap is the most commonly used cleansing agent. It improves the cleaning action of the water. It acts as a surfactant and removes the dust particle, the dirt and the other things which are there in the form of a fat sticking to the clothes surfaces. Now when the saponification is done, the oil of fat is hydrolyzed with using caustic soda NaOH. The soap formed is existing in the colloidal form, which is being precipitated out by putting up by adding NaCl solution. The soap thus extracted out by adding sodium chloride solution leaves behind glycerol in the remaining solution, which can be obtained by fractional distillation. The soap are of various types, but what we need to understand first is this, that the soap works, they shows the cleaning action by the micelle formation, which you have already done in the surface chemistry chapter. Now the other most important thing, now let us understand the different types of soaps which we use in our day-to-day life. Types of soaps. The soaps which we use in our day-to-day life are of many types, like toilet soaps. Toilet soaps are the soaps which are used for bathing purposes. These are the soaps which are made from the better quality oils of fat, and the perfumes or deos are added in order to make them more pleasant. Then we have floating soaps. Floating soaps are the soaps that floats, basically used in your bathtubs. These are the soaps which are formed by passing air bubbles before its hardening or solidification process. Those air bubbles makes the density lighter than the water, lesser than the water. That is why those soaps floats. Then we have transparent soaps. The transparent soaps are the ones which are actually the soaps which are made transparent by adding ethanol, and the excess of the solvent is then evaporated. Now the addition of ethanol makes it transparent. So that's why we can get transparent soaps. Then medicated soaps. Medicated soaps contains bithionol, the antiseptic, and they are the one which we commonly uses for cleaning our hands. Then we shaving soaps. Shaving soaps are those which are used for shaving purposes. They mainly contain glycerol and sodium rosinate as the extra things along with the normal soap. The glycerol prevents the rapid drying of the lather, and the sodium rosinate is a gum basically of rosin, and so its salt is formed sodium rosinate, which actually gives rich lather to the shaving soaps. Then we use as laundry soaps. Laundry soaps are the ones which are used for cleaning, cleaning the clothes and other things. Now these laundry soaps along with the normal soap contain sodium silicate, sodium rosinate, sodium carbonate and borax. Then we also use soap chips. Soap chips are nothing but small pieces, chips of the soaps which are formed by putting up a thin layer of the liquid soap on a cool cylinder and then scraping off its thin layer, which gives out on solidification, of course, which gives small chips of the soap. So this is how we use different types of soaps in our day-to-day life. Now what we need to understand is what are the advantages of the soaps are. The biggest advantage of using soaps is that they are biodegradable. They doesn't lead to any kind of pollution. They cannot sustain for a longer time. They get easily being broken down into smaller molecular species by the microbes. So they are biodegradable. That's the biggest advantage. But the other disadvantage with the soaps is that they doesn't work in hard water. Now the question comes is why they doesn't work in hard water. The reason is because they form salts with calcium and magnesium ions. Now we know this, like if this is the soap, we have C17H35COONA, this is sodium stearate. Now when it comes in contact with the sodium chloride, like which is there in the hard water, it's there in the hard water. So what we find is C17H35COO, calcium stearate is formed like this. So what we find is that this salt formed of the calcium doesn't lead to the formation of the micelle, because of which they won't be able to show the cleaning action. That is why the soaps, when the clothes are, when they are washed in the hard water with the soap, with the help of a soap, are not able to be cleaned properly. We are not able to clean them properly. The soap doesn't show their complete action in hard water, because the moment they come in contact with the calcium and magnesium salts which are there in the hard water, these salts are formed which cannot be broken down, and due to which the micelle formation doesn't take place. Now let us, after understanding soaps, now let us understand the detergents. Now let's talk about the synthetic detergents. See, the detergents are mainly out of three types, but first we need to know what detergents are. Anything other than the soap used for cleaning purpose or as a cleaning agent is called detergent, synthetic detergent. They are synthetic because they are synthetically or artificially prepared. They are of three types. They can be anionic detergents, cationic detergents, or non-ionic detergents. Now let's talk about first anionic detergents. They are the most commonly used household detergents. They are the sodium salts of alkyl sulfonates or sodium salts of alkyl benzene sulfonates. They are having long carbon chain along with the sulfonic group, and this molecular species which will be leading to the formation of micelle is an anion. That is why these detergents are called anionic detergents. Like the example, sodium lauryl sulfate or sodium dodecyl benzene sulfate. This is a carbon chain, benzene sulfonic acids. So they are either a sodium salts of hydrocarbon chain, alkyl sulfonates, or sodium salts of alkyl benzene sulfonates. Now they are the most commonly used household detergents, as I have told you, and they are also used in making, they are used in toothpaste and in the common detergents which we use in our day-to-day life. Then cationic detergents. In this, the main carbon chain which leads to the formation of the micelle is not an anion, it's a cation. So these are quaternary ammonium salts of long hydrocarbon chain, and the cationic part is neutralized by either bromides or acetates. So these, like this example, cetyl trimethyl ammonium bromide. In this trimethyl ammonium salt, so it's a quaternary ammonium salt of bromide or acetate. This is a salt of a bromide. So this long carbon chain is having a nitrogen group which is converted into a quaternary ammonium salt by trimethyl, and then bromide is there to neutralize it. So these cationic detergents are having what cation as a major molecular species which lead to the formation of micelle, due to which they shows their cleaning action. Now they are very expensive in nature. Therefore they are used in very expensive detergents which we use in our day-to-day life. Then we have non-ionic detergents. Non-ionic detergents are esters. They are esters of long chain fatty acids and polyethylene glycol, like this one. So these are the polyethylene glycol molecules with long chain fatty acid. Now these actually are very expensive, and they are having a germicidal and other properties, and they are basically used in your liquid dishwashing as a liquid dishwashing detergents. Now what we need to know with the detergents, most biggest advantages, they can be used in hard water, but the disadvantage is that they actually are non-biodegradable. That is why nowadays we have realized that if we keep the carbon chain of these detergents as straight as possible, the microbes will be able to act on them, and they will be able to break down into the smaller species. So the detergents which are unbranched are biodegradable detergents, and that is how we have now been able to form biodegradable detergents also. So mainly the non-ionic ones basically nowadays we use which are biodegradable. Otherwise, if the chains are branched of the hydrocarbon part, they are the non-biodegradable.